Alex and Hope were trying to solve -6 times x is greater than 24. Whose inequality shows the solution? Show your work.
Whose do you think shows the correct answer? Alex or Hope? What's the, Luis, what do you say? Alex? Okay, what's the difference between Alex's answer and Hope's answer? What's the main difference for Luis?
Greater than sign and less than sign?
The signs are different. So like one has a greater than sign and one has a less than sign. What's interesting is you might think Alex's is right because the sign matches what it is in the problem, but it actually is Hope's that is correct. And we'll learn why today, okay? So we're just going to be solving simple equations with multiplication and division. And it takes a while for these to load when I'm recording, so.
How does using multiplication or division to solve an inequality compare to using the same operations to solve an equation? Think about this question during the lesson. Gina's pet pot-bellied pig is on a diet. It can have no more than 18 ounces of pig food per day. The bag's label says that each scoop holds 4 ounces of food. How many scoops can Gina feed the pig without going over 18 ounces? Since the problem states that the pig can have no more than 18 ounces, we can write an inequality to represent the situation. The number of ounces per scoop times the number of scoops she feeds him must be less than or equal to the maximum daily number of ounces. Which part of the inequality is unknown?
Which part don't we know? The ounces per scoop, the number of scoops we get the pig, or the maximum number of ounces? Luis?
Number of scoops?
Correct.
The number of scoops is the unknown. Use the variable s to represent the number of scoops. Each scoop holds 4 ounces. The maximum daily number of ounces is 18. Why should the inequality use the symbol for less than or equal to?
Luis?
It
It could equal 18, yeah. So we want to include that equal to line down there.
The total can be equal to, but not greater than 18. You can solve the inequality just like you would solve an equation. Use the inverse relationship between multiplication and division and the division property of inequality to isolate the variable. The number of scoops, s, is less than or equal to 4 5/10, or 4 1/2.
So we could feed the pig anything up to 4.5 scoops. Okay, another way we can solve this, okay, whoops, is to, instead of dividing by 4, we can multiply by 1/4. Remember, multiplying by 1/4 and dividing by 4 are the same thing. So we can do that instead. The little thing will go away, there we go. Then we've got 1/4 times 18, which is 9/2, which still reduces to 4.5. So you still get an equivalent answer, no matter which way you solve it.
Now let's graph the solution to our inequality. The maximum value of S is 4 1/2. Let's check that our solution is reasonable in this situation. Gina can use parts of a scoop, so S can include fractions and decimals. However, Gina cannot feed the pig a negative amount of food.
Okay, so if you look, they actually even used an open circle on 0 because she really can't feed the pig no food, but she can feed the pig anything up to no food. So like the littlest bit up to 4 1/2 scoops.
Gina can feed her pet pig up to 4 1/2 scoops of food.
Okay, so let's try one. Okay, here we've got the inequality D divided by 7 is greater than 15. This is showing division. D over 7 is D divided by 7. So what's the inverse of dividing by 7? Maddie? Multiplying by 7. So we're going to multiply each side by 7. So we have a 7 here and a 7 here. This symbol stays the same. Okay. The times 7 and divided by 7 cancel each other out. So I'm left with D is greater than. I've got to figure out what 15 times 7 is. 105. Okay. So here we've got a number line that does include the number 105. Am I going to have an open circle on 105 or a closed circle on 105? Louise? Open. Okay, the closed circle means it includes the number, the open circle means it doesn't. Does this symbol tell us we need to also include the number 105? No. We're just going to have an open circle. And then we want numbers that are greater than 105. Where are the numbers greater than 105? On the left or on the right? Louise? Right. The right side. Francis solved the inequality 5G is greater than 35. I'm going to write that up here. Or greater than or equal to 35. She said that 7 is a solution. Do you think she is correct? Louise is shaking his head yes. David's like maybe yes. Yep. Okay, so to solve this one, I would divide by 5. Okay, those cancel out. And 35 divided by 5 is 7. And the equal to sign means that it can include 7. So yes, 7 would be a solution. Okay, if it was just greater than, would 7 be a solution? No, because it's greater than 7. 7 is not greater than 7, so that wouldn't be a solution. Questions so far? Very similar to what we've done so far. I'm taking a really low potential. Okay. Now we're going to be doing an inequality that has a negative number next to the variable. Okay, the reason they're showing you an example like this is because it does change how we solve it. This is going to be different than equations, and it's only true when you have inequalities. Okay, so this process will only be true for inequalities. Okay, so they said they want us to complete the first step of the solution. Okay. So we're going to start with a negative 3/4 m and 17 and this less than or equal to sign, because that's what we have in the equation. Okay. Now, right here, I'm taking negative 3.4 times m. What is the inverse of that? Louise?
Negative 3.
No, it's not negative 3.4. Yours be like, well, we would divide by negative 3.4.
Oh, yeah.
So, because like we're multiplying these are multiplying. So the inverse would be dividing. So we're going to divide by negative 3.4 on the left and by negative 3.4 on the right. Okay. Now, is that like, that was it, okay. When you divide, it's going to become a negative 5. Okay, but you notice that our inequality symbol now has flipped around. Okay, and that's where it's different than an equation. Dividing by a negative value reverses the inequality symbol. Just because we went from like a negative on the left to now being positive, we've got to flip-flop our inequality sign as well. So, instead of doing m less than negative 5, our solution is going to be m greater than or equal to negative 5. And that's the big trick there. You solve it like normal, but you've got to flip the inequality sign. And that only happens when you're dividing by a negative number. Okay? 90% of the time, you're probably going to have a positive number and it stays the same. But once that's negative, you do have to change the inequality sign. Okay, even if you end up, sometimes they'll give you problems like this. I'd rather know what a positive m is, not a negative m. So you've got to think about this like a negative 1. And then you divide by negative 1, or basically you just change the signs of everything. This became positive, this flipped around, and this became negative. So if a negative m is greater than or equal to 7, a positive m is less than or equal to negative 7. Okay. Ooh, lots of decimals. Okay, we're going to solve each inequality and then we're going to graph it. In A, I've got 149.76. Hold on a second. Wait, let me grab some.
Sometimes we would sing this, that was our lunch thing last year, but. Yeah.
Okay, so I'll have the kids prepared. Thank you. We start stations this week. Oh, pretty much Wednesday. Started being Wednesday. So you guys will get to do, not this week, but next week. Yeah, 8th grade will get to go first. Okay. Anyway, back to this problem. And 149.76 is greater than negative 19.2 times x. I'm just going to rewrite it down here. Okay, they have the x on the right side, which doesn't really matter. We're still going to solve for x. What's my inverse here that I'm going to use to get rid of the negative 19.2? Louise? No, actually, this is negative 19.2 times x. So what's the inverse of timesing? What's the opposite? Maddie?
Division.
Division. So we're going to divide by negative 19.2. Okay, and because we're short on time, I want to make sure we get through this. I'm just going to use a calculator real fast. What? Oops. Okay, and because one of my numbers is positive and one is negative, my answer will also be negative. Okay, and I'm going to flip my inequality symbol. So we have the answer negative 7.8 is less than x. We can also rewrite that to have x on the other side by just taking everything and like flipping it over. So it's the same as x is greater than negative 7.8. Sometimes we take it and we just rotate it, flip it over. So then we would find negative 7.8. Just like here. Okay. Are we going to have an open circle or a closed circle? Do we include 7.8 in our answer? No. So if we don't include 7 or negative 7.8, it's going to be an open circle. And we want to know where x is greater than this. Where is x greater than my circle there? On the left or the right? Louise? The right. Greater is always on the right. Okay. Let's try another one. This one is set up like we normally like it with the variable on the left side. Okay, I've got negative 3.25 times y is less than negative 61.75. And what is the inverse of multiplying, Zayden? What's the opposite of multiplying? Dividing. So we're going to divide both sides by negative 3.25. Okay, these will cancel out. And then when I divide those, am I going to end up with a negative number or a positive number? Louise? Positive, because I had two negatives. Okay, and then because I divided by a negative number, I'm going to flip around my inequality sign. So the answer would be y is greater than 19. So I'll find 19. Am I going to have an open circle or a closed circle on 19? Did I include 19 in my answer? Nope. Everything up to 19. So we'll use an open circle. And then I want where y is greater than. Where's y greater than that? Louise? All right. Right, this is the big difference, the dividing by a negative. You gotta flip the sign around. That's why the one answer was right, even though it didn't look right in our first example. Okay. So here I've got another inequality. This time it's a division inequality because I've got r being divided by negative 2.5. We're going to solve it. Okay, so we're going to do the inverse of dividing, which is multiplying. And we're going to take everything times negative 2.25. And over here, times negative 2.25. And I end up with r is less than or equal to negative 15.75. Okay, I had to change the sign again. So if I divide or multiply by a negative number, I've got to change the inequality symbol. Adding and subtracting, it doesn't really matter. That doesn't change the inequality symbol, but multiplying and dividing does. Okay. So if we want to graph this, we would find negative 15.75. It is a closed circle because it's or equal to. And then we want numbers less than that, so we're shading to the left. Okay, let's try these. Okay, our first one is k divided by negative 0.5 is less than 12. Okay, what is the inverse of dividing? Maddie? Multiplying. So I'm going to multiply by negative 0.5. Okay, those cancel out. And then what is 12 times 5? 60, but I've got a decimal, so that's actually going to equal 6.0. Okay, and because this was a negative number, this answer is going to be negative, and I have to flip my inequality symbol. Okay, so if I'm going to graph that, let's just put negative 6 right here. Does my answer include the number negative 6? No. So I'm just going to draw a circle around negative 6, and I want numbers greater than that. Where are they greater? David? Left or right? Right. Okay, and then we've got negative 5/4 h greater than or equal to 25. Okay, this is a multiplication equation or inequality, so I need to divide to do the inverse. Instead of dividing by 5/4, so what am I really going to do? Multiply by the reciprocal. Multiply by the reciprocal. So we're going to multiply by negative 4/5. And I'm going to do that on both sides. I'm going to change this to a 25/1 to make it easier. Okay, these things all cancel out and reduce. Okay. Can I cancel anything on the right side before I multiply? What can I do? 5 and 25. That's now 1. So 5. Okay, so now we take 5 times negative 4. Negative 20. Negative 20. Okay, and then 1 times 1 is 1, so it's just going to be a whole number. And this was a negative number we were multiplying by, so I have to flip my symbol around. And now I have h is less than or equal to negative 20. Okay, does negative 20, there is negative 20 part of my answer? Yes. So I'm going to fill in my circle. And then I want less than that. Where is it less than, Maddie? To the left. Okay, the graphing will be the same as what it was before. That didn't change. The big thing is knowing if whether your symbol stays in the same direction or if it changes opposite because of a negative number. So yes, they said solving inequalities with multiplication and division is the same as solving equations with multiplication or division when the values are positive. Use the inverse relationship between multiplication and division to isolate the variable. When multiplying or dividing by negative values, the inequality symbol is reversed. Okay. So, if we're looking at A, B, and C here, do any of them require you to flip the symbol to get your answer? Do any of them make you have to flip your symbol around? So Louise is shaking her head, I'm shaking her head. Which one? Or which ones make you flip the symbol around? Louise?
B. And C.
Just C. Okay, here's a -4 that we're dividing by. B has a negative number, but it's on the other side. We're not actually like, you're always going to look at the number with the X, and that's what determines if you move the symbol or switch the symbol around. So because the -4 is here on C, that one you've got to flip the symbol around. On B, it's a positive, so it stays the same. And on C, or on A, it stays the same because that number's positive as well. Okay, the negative right here on B, that doesn't matter. This is the number you're dividing or multiplying by. That's what determines. Any questions? Very similar, one new thing basically. Okay, I have your homework assigned. You got like 7 minutes. You guys can get started on it. But like, I think the computer part's already open. You can go grab some tablets. You can work on ISO, you understand what this is. Okay.
Can I go get
Yep, you guys can go grab tablets.